All right, guys, welcome to the Tutor Learning Center. This is JDTutor, and I'm here to teach you Algebra 2, more from the Springboard. Let's do, last video we did lesson 1, 2, but we are going to do some activities from lesson 1, 2 Springboard, and they're much similar to the ones that we've already did, but let's look at them. All right, guys, so lesson 1, 2 here. A taxi company charges an initial fee of $3.50 plus $2 per mile. Use this information for items 10 through 16. This sounds very familiar. Sounds much like the inner tubes, right? Let's take a look over here at number 10. So the length of the trip is going up by 1 each, right? 1, 2, 3, 4, 5. And the cost is going up as well by every 2 additional cost, right? 2 additional dollars per mile. That looks very familiar to what we did with the inner tubes in lesson 1, right? All right, so let's make a table that shows 1, 2, 3, 4, and 5 miles, and that's what we did here. So take a moment, guys, pause the video and write down the answers to number 10 here. All right, but as we're still going along, guys, I want to point something out to you. Didn't we also make these ordered pairs? I think we did on the last one, didn't we? Might as well go ahead and do that this time, right? Just keep that in mind with the comma here, comma here, comma, comma, and comma. And remember our independent and dependent variables, X and Y, right? All right. And also, guys, let's look at Y equals MX plus B. Didn't we have that before, guys? I think we kind of modeled that as well. All right, we're going to be taking a look at that, I bet, shortly, won't we? All right, so number 10 is done. All right, write an equation in 2 variables that model the situation. Explain what the independent variable and the dependent variables are. So remember our Y equals MX plus B. Let's take a look here. So Y equals, we're going to put the 2x first. I don't like for that 2x to be over there. Really not in slope intercept form. So 2x plus 3.5. There we go, guys. All right, that is for number 11. And don't forget our X represents the length, the trip in miles. The dependent variable is Y. The independent variable is X. Number 12. Graph the equation. Be sure to include a title for the graph and for each axis. And one wasn't on the last graph. They were going up like that on lesson 1, and then we had a line going up. Oops. All right, let's look at it. Number 13. Number 12. Yep. So they took what was here, 1 and 550, 2 and 753 and 954 and 1155 and 1350, and brought it here, right here on the graphs, right? All right, 1150, and then 550 right here. I mean 5 and 1350. All right, guys. So that concludes number 13. Number 12, excuse me. Number 13. Describe one advantage of the graph compared to the equation. All right. So sample answer, the graph makes it easy to see that the trip length increases. The cost also increases. Number 14. Is the equation that models this situation a linear equation? Yes, it goes up in the straight line. Let's look at the answer, though. The graph of the equation is a line. Let's look at number 15. Pause the video, guys, if you get behind. What are the slope and the y-intercept of the graph? What are the slope and the y-intercept of the graph? Of course, we know the 2 should be the slope and the 3.5 should be the y-intercept. Let's look at it. The slope is 2. It represents the $2 charge per mile for taking the taxi. And the y-intercept is 3.5. It represents the initial fee of $3.50 for taking the taxi. All right, number 16. Shelley uses her phone to determine that the distance from her apartment to Blue Cafe is 3.7 miles. How much will it cost Shelley to take a taxi to the cafe? It will cost her $10.90. And if you do the calculations, let's insert $10.90. 3.7 miles. So let's go to here and we'll just kind of draw that in there. And that's going to cost her $10.90. All right, guys. All right, number 17. All right, choose the equation that is not linear. That is not linear. Well, we look at this, and this does look like y equals mx plus b, right? With our fraction of rise over run. So that's good. So we need to choose one that is not linear. Let's look at C while we're here. This can be rearranged and solved into y equals mx plus b. That's good. So let's look at D. Dx equals -4. That's just a straight line. That's linear anyway. There's no slope. When you have no slope, you have a straight line, right? Straight across, right? Or up and down, right? So that's good. Let's look at B. That's our only alternative, right? So y equals 4 over x. We can't have our slope over the number per something or times something, because a number is supposed to or can go in there, right? So you can times your slope times that number, right? Not divide it. All right, so the answer is B. All right, let's see, yes, so the answer is B. Number 18. Let's look at what is leading us into 18. A zoo is building a new large cat exhibit. Part of the space will be used for lions and part for leopards. The exhibit will house 8 cats in all, so it's going to house 8 cats. Expenses for the lion would be $8,000 per year. So per year, so 8x, I'm just going to put an X in the place of that. And expenses for the leopard will be about $6,000 per year. So I'm putting an X variable in the place of per year there. Okay, that is a variable, not an X. I'm not crossing that out and just leaving it. I'm putting an X variable right there to show you. Okay, so items 8 through 21. Write an equation that can be used to find y. Okay, so y equals the yearly expenses for 8 cats in the exhibit when X of the cats are lions. So we know that X are the okay, so X of the cats are lions. We can say X of the cats are lions, but then there are 8 cats as a difference from that. So a difference from that. So let's apply it, guys. There's more to this. Okay, so let's create an equation, they say. And I'm going to rewrite this for number 18. Okay, y equals the 8,000 for the lions, okay, per year, plus the 6,000, okay, and then the 8 minus the X. Sorry, I said x minus 8, but it's 8 minus the x. All right, guys, and there's your equation. Sorry about that, guys. Oops. And that's going to be 8. 8. I'm sorry, guys, I'm doing it again. Hold on. 8 minus the x, right? All right. So let's look at number 19. Graph the situation. Be sure to include a title for the graph and for each axis. All right. So the same thing, guys. We're looking at number 19, our X and Y axis, right? And it's going to be, we know it's going to be, we're starting from 0, looks like. Remember in our last set where it actually went down to at the 0 mark, right? For the y-intercept. You guys remember that? All right. So it would be 0 and then 48. And they're going to go up by 2. All right. 150. 150, 252, 354, so 354, 456, 558, yep, 660, 660, 762, and 864. Okay. All right. So we just graphed that for number 19. All right, number 20. Are all the points on the line you graphed solutions? Are all the points on the line you graph solutions in this situation? All right, let's take it number 20. No, they're not. X represents the number of lions, okay? So X must be a whole number. Also, no more than 8 lions can be in the exhibit. So the greatest value of X is 8. Thus, only the points on the lines that are solutions are those with an X coordinate that is a whole number no greater than 8. All right. Write that down. Take a moment, pause the video, write down number 20. Number 21. What would the yearly expense be if 5 of the cats in the exhibit are lions and the rest are leopards? Explain how you found your answer. So number 21. So the yearly expenses would be 58,000. All right. So the graph includes the point 5 comma 8. I mean 5 comma 58. Excuse me. Okay, the point represents a yearly cost of 58,000 when 5 of the large cats in the exhibit are lions. So that is an easy way to tell that. That's why I wrote this. So 5 and 58.